Hey there, class. So in the last video, we took a look at how to find the area of a couple types of polygons, rhombuses and kites. And in this next couple of videos, we're going to take a look at finding areas of regular polygons. Now, I will tell you that this is probably one of the more difficult topics that we're going to cover for the rest of the year. If I had to pick one, I might pick this one as the most difficult topic for the rest of the year. So we're going to spend some time on it. We're going to spend 3 videos on looking at how to find the area of regular polygons. So just stick with it and keep working, and you'll get through it. So today we're going to start out just with basics. We're not going to get into the difficult stuff yet. We're going to take a look at just the vocabulary of the different parts of regular polygons. So let me bring up the let's see, where did that go? All right, so let me bring up some examples here and some vocabulary. So first vocabulary term we have is a regular polygon. We've talked about this already in the past, but just to recap what that is, a regular polygon is a polygon where all of its sides and angles are congruent. So a regular polygon is one that is both equilateral and equiangular. All of the sides here are congruent to each other, and all of the angles here are congruent to each other as well. And when both of those are true, we call it a regular polygon. You can almost think of it as like the most perfect polygon of a certain type. Like a quadrilateral, the most perfect quadrilateral is a square. All 4 sides congruent, all 4 angles congruent. This pentagon here has all 5 sides congruent and all 5 angles congruent. So in a kind of a way, it's like a perfect pentagon. Now there are some specific parts that we're going to learn about, but a couple important things about regular polygons. One of them is that it's possible to circumscribe a circle around a regular polygon. That means if you have a regular polygon that's both equilateral and equiangular, you can always put a circle around that polygon that'll touch every vertex one time. It is also possible to inscribe a circle within a regular polygon. So it's possible to draw a circle on the inside that just touches each side or is tangent to each side at one single point. And it's going to happen at the midpoint of each side. So this is an example of an inscribed circle within that regular pentagon. Now there are a bunch of different parts. There's about 4 different parts that we're going to define within a regular polygon. So we'll go through those here. Might be a good idea to write down or take notes on this vocabulary as we go through this video. So the first one is the center of a regular polygon, and that is the center of the circumscribed circle, or it would also happen to be the center of the inscribed circle. So in this example, point A is the center of this regular polygon. If you drew a circle around it and hit all the vertices once, A would be the center of that circle, and so we also call it the center of the regular polygon. The radius of a regular polygon is the distance from the center to the vertex, so one of the vertices. It also happens to be the same as the radius of the circumscribed circle. So in this example, AD, segment AD, is an example of a radius because it starts at the center and ends at a vertex. And it also happens to be the radius of this circumscribed circle. We can also talk about the radius as if it were the distance. So if segment AD maybe had a distance of 10 units, then we would say that the regular polygon has a radius of 10. This other segment within the regular polygon is called the apothem, and that is the distance from the center to one of the sides at a right angle. So for example, the distance from point A to point C, we would call that the apothem. That's the distance from the center to the side of the polygon. It also happens to be the same as the radius of the inscribed circle. If you drew an inscribed circle, it would hit each side or be tangent to each side at the midpoint, and that radius here would be called the apothem. So segment AC, that's what we call it. We call that the apothem of the regular polygon. One other part that we have is called a central angle. And that is an angle within a regular polygon that's formed at the center by two different radii. And this would be an example here of a central angle, angle BAD. We would call that a central angle because it's formed by these two radii. AB is a radius, AD is a radius, and so that angle formed is called the central angle. Even though angles CAD or angle CAB are formed at the center, we wouldn't call them central angles because they're not formed by radii. That one's formed by an apothem and a radius. So a central angle is always formed by two different radii. There's an important thing to know about how to find the measure of that central angle, and it's pretty simple. The measure of a central angle is just 360 divided by the number of sides. And how do I get that to go away? So, for example, in this case, we have a hexagon. We have 1, 2, 3, 4, 5, 6 sides. And so 360 divided by 6 would give us a central angle of 60 degrees. We'll take a look at 3 examples of identifying some of these parts. So in this case, we've got, it looks like 1, 2, 3, 4, 5, 6, 7, 8. We've got a regular octagon. And I want to identify some of the different parts that can be found in this octagon. This would be a good time to pause the video if you want to come up with those parts on your own. We're going to name these different parts that we have. Well, let's see what we have. So the center is going to be point P. This is the center of the circle or the center of the polygon. The radius would be a segment that goes from the center to a vertex, and there's 2 of them shown here. From P to W, that segment PW is a radius, and also PV, that is a radius too, because it starts at P, ends at B. An apothem would have to start at the center and go to a side at a right angle. So PY is an example of an apothem. A central angle is formed at the center by 2 radii. So this angle here, WPV, would be an example of a central angle. And to find the measure of that central angle, we would take 360 divided by the number of sides. And 360 divided by 8 is 45 degrees. So those are your center, couple of different radii, apothem, central angle, and how to find the measure of a central angle. Let's take a look at another example. Here we have a regular hexagon, so we have 6 sides, 1, 2, 3, 4, 5, 6, and we're going to identify the different parts that are found within that hexagon. So if you want to try to find those on your own, you can pause the video here and jot those down on a piece of notebook paper or piece of scratch paper. Well, let's see what we have. So the center is going to be point A. Radius here would be either segment RA or UA, or you could always name those in reverse. AR and AU would also be acceptable names there. The apothem shown is segment VA, or segment V or AV would be fine too. A central angle would be angle RAU, and to find the measure of that central angle, we would take 360 divided by the number of sides. There are 6 sides, so 360 divided by 6 is a 60-degree central angle. This angle in here, RAU, measures 60 degrees. And we divide it by the number of sides, by the way, because all the way around would be 360 degrees. So we're just dividing it up for the section that we have, which is only 1/6. Or, there are 6 sides, so this is 1/6 of that 360 degrees. Well, let's see one more example of identifying these parts. So here we have an equilateral triangle, which is a regular polygon with 3 sides. So we'll identify an example of the center, radius, apothem, central angle, and then find the measure of the central angle. Well, let's see what we have on those parts. So the center of this polygon is point A. A couple of different radii you could identify would be segment NA or segment EA, because those both start at the center and end at a vertex. So those are both radii. The apothem here starts at the center and goes to the side at a right angle, so that would be segment AM. The central angle has to be formed by two radii, so angle NAE. This angle in here is a central angle. And then the measure of that central angle is 360 divided by the number of sides. So there's 1, 2, 3 sides, and 360 divided by 3 is 120 degrees. So this angle in here has a measure of 120 degrees. So to recap, the things you should be able to do from this video are to identify those 4 different parts within a regular polygon. You've got your center, radius, apothem, and central angle, and also be able to divide the number of sides, 360 by the number of sides, to find the measure of the central angle. In the next couple of videos, we're going to learn how to find the area of a regular polygon using those different parts. But for right now, just focus on that vocabulary and being able to identify those different parts. All right, I hope that video was helpful. If you have any questions about the parts of a regular polygon, make sure you jump on my Zoom office hours or send me an email. I'd be happy to help you out.